Okay. Hi everyone, we are from group 3. So for this assignment, we are taking a pirate ship from a theme park. This ship will rotate 360 degrees, but for this assignment, we are going to find the velocity, force, and acceleration of the ship at varying angles. So this is the information of the ship, like the average mass of people on the ship, and there's 50 people on the ship. Also the mass of empty ship. So we have calculated the total mass of the ship, which is 9,375 kilogram.
Okay, so for the first method, we are going to use principle of work and energy. As we all know, principle of energy includes work done due to weight only. In this case, we have to find the work done at point A, and we will get as shown here. And the answer we get negative is because we assume the weight is pointing downward and the direction of the distance is pointing upward. So since the direction is different, so we assume it as negative. Same goes to work done due to weight at point B. And then we just substitute the value inside the formula. TA plus summation U A to B equals to TB. TA is a kinetic energy, which is 1/2 mv squared. Since VA, the velocity initial is at 0, so TA is equals to 0. And then we just substitute the value UWA and UWB inside the summation of UA to B, and we have to find the velocity at point B. And we just solve the equation, and we will get VB equals to 11.2989 meter per second.
Okay, for another method to calculate the velocity is conservation of work and energy. The equation for the conservation of work and energy is TA plus VA equals to TV plus VB. TA, which kinetic energy, for the formula is equals to 1/2 mv squared. For potential energy, the equation is, the formula is using weight times the height. The potential energy for the sign we use is depend to the datum of the datum we assume in the diagram. For this question, we assume the datum is below here, so the particle is above the datum, so we assume the potential energy is plus for the positive sign. So for the TA, kinetic energy at point A, since it is static and no velocity, so the TA is equals to 0, and we substitute it, the value inside. For the W is the weight is we have calculated before, we substitute in, and the height, all the value is substitute in, and we solve the equation. We will get the answer for velocity V is equals to 11.2989 meter per second.
So the next step is we are going to find the force exerted on this motion. So to calculate the force, we will use the formula which is Newton's second law, Fn summation of Fn equal to ma. For this case, we use An because this is a cylindrical motion. So this is the free body diagram. As we can see here, the wake is pointing downwards and the force moving upward. So the formula is for the F component we have F minus W, which we can see the wake is pointing downwards. That's why the W is negative. So the M is mass and An is V squared over rho. Substitute the value into the formula. We have the equations as shown this. So this W cos 60 is because we have shift the axis like this. That's why we have cos 60. So by solving this equation, we will have the force which in Newton. So the next step is we have to calculate the acceleration constant, which is tangential acceleration. To calculate this acceleration tangential, we have to use the formula of period, which is t equal to 2 pi square root L over g. By substitution the value into the equation, we will get the t, which is 7.2330 seconds. So when we have the t, we will substitute the equation into the kinematic equation to find the AC. The V we have calculated earlier, and the V naught is 0. The AC is what we want to find, and the t is 7.233 seconds. So by solving the equation, we have 1.5621 meter per second squared, which is this is the acceleration tangential. So the next step is we have to calculate the magnitude of the acceleration by using this formula. By solving this, by substitute the value into the equation, we will get 9.9437 meter per second squared. That is the magnitude of acceleration.
Okay. So now we have compiled the velocity, force, constant acceleration, and also the magnitude of acceleration for 30, 60, 90 and 180 degrees. As you can see, all of them they increase as the angle increases. So in conclusion, we can say that as the pirate ship moves higher, we must need a greater force to overcome the gravity.